sold over any 3-day period. If we tried the simplest approach, we would take every possible group of 3 days, sum them, and compare. That would work, but it would repeat a lot of unnecessary calculations. The sliding window pattern helps us avoid this repetition. Let's walk through it step by step with the code on screen. First, notice that we take the sum of the first 3 days. This becomes our initial window. At this moment, the window sum is 20 plus 25 plus 30, which is 75. We also set this as our current maximum. Now comes the sliding part. Instead of recalculating the sum from scratch for the next 3-day period, we slide the window forward by 1 day. That means we remove the first day's sales from the sum, and we add the next day's sales to it. For example, when the window moves from 20, 25, 30 to 25, 30, 15, we subtract 20 and add 15. The sum becomes 70, much faster than adding 3 numbers again. This process repeats for every step. Each time, we update window sum by subtracting the element that falls out of the window and adding the new element that comes in. Then we compare it to max sum to keep track of the largest one we've seen. By the end, the maximum sum we found was 85, which comes from the days 30, 15, 40. This pattern is very efficient because instead of recalculating sums repeatedly, it reuses most of the previous work and just updates the window with 2 quick operations. That's the essence of the sliding window algorithm.